Hello friends, today in this video we will discuss about the mole concept and cover the following topics. First of all, what is a mole concept, then what is a mole, then how to find the number of moles, and then some numerical problems over the mole concept. So let us start with the first topic, and that is what is a mole concept. So, mole concept. Mole concept is nothing but just a way to find the number of moles. It is a way or a method to find the number of moles. To understand this topic more, or this concept more appropriately, let us take an example. Example of a bank. So, let us assume that in a bank there is a box containing coins of rupees 5, and the problem is they have to count the total money in the box. So, to count the total money in the box, what they can do? Let me just clear this portion. So friends, yes, so what can they do to count this money? First way, they can open the box and count the total money. But as you know that to count so large number of coins is a very time consuming method. So now what they can do to count the money easily and faster? They have another way, that is to find the total number of coins. They can weight the complete box and then divide it with the weight of a single coin. By this, they can easily get the total number of coins, and then just by multiplying the total number of coins with the denomination, that is 5 multiplied by the number of coins, they can easily find out the total amount. So friends, why I have discussed this example with you? Because the same concept is used in the mole concept. Just like the number of coins are very large, in science we have a very large number of atoms present in an element or a compound. So to count them one by one is not an easy task. So for that we use this method. Similarly in science, let us discuss how we can use this method in science. So friends, in science we can replace the coins with atoms or we can say particles, and the box which contains the coin as an element which contains atoms, or a compound which contains molecule which can also be considered as a particle. So in science what we have to count is the number of moles. Similarly, like in the case of example, we count the number of coins. Here we have to count the number of moles. So before starting this topic, first of all we have to understand that what is meant by the term mole. So now scientist has already performed an experiment that when the weight of an element is equal to the atomic mass or molecular mass of that element and compound, then the number of particles or atoms, or we can say molecules in the case of compounds, present in that amount is equal to the 6.022 into 10 raised to the power 23. That means that whenever we take the amount of any element or a compound equal to its atomic mass, or we can say that molecular mass in case of compounds, then always the number of particles present in that amount is equal to 6.022 into 10 raised to the power 23 particles. We can take any element or any compound, the number of particles will be the fix. Now this number is nothing but considered as 1 mole. It is a similar case that like we call 12 as 1 dozen. And similarly we call 6.022 into 10 raised to the power 23 particles as 1 mole in science. Now we have cleared that what is a mole. Now let us go to the formulas by which we find the number of moles from the mass. Now again, with the example of that bank, we will find out the formulas for finding the number of moles present in an element or a compound. So just like in the case of bank, we use the formula that the number of coins is equal to the weight of box divided by weight of single coin. Now in science we will replace the number of coins with the number of moles. One thing I want to clear here is that we can use the term the number of particles, but as we know that the number of particles are too much large, so we just consider as the number of moles. Now the number of coins from the example, the number of coins here is now equal to the number of moles, and the weight of the box is equal to the total whose in which the number of particles we want to find. And now below is the weight of single coin. Now in our case we have to consider the weight of single atom, but as we know that we cannot find easily the weight of a single atom, so that is why we use either we use the let me write that relation again. Either we can use the atomic mass or we can use the number which is equals to 1 mole. As we know that here we are taking the total number of mole, we are not taking the number of particles. So for this case we know that our weight which we are taking is equal to the atomic mass or molecular mass. So now we can we are not considering a single particle, we are considering 6.022 into 10 to the power 23 particles at a time, and we are finding the number of moles on that basis. So here we will not consider the weight of a single atom, we will consider the weight of 1 mole. And weight of 1 mole is nothing but the atomic mass or molecular mass. So the one relation we have derived here is this, that the number of moles is equal to the, here we can write it, the total mass as given mass that will be provided us in the numerical, that given mass upon the atomic mass. This is our first relation which we have derived to find the number of moles. Now the second relation is also derived from the same case, that is the number of moles can also be written as, if we know how much the number of particles we have, that is the given particle, and for the given particle, the particle which we have, that the atomic mass is equal to the 6.022 into 10 to the power 23 particles, that is our standard for 1 mole, we can write the given particles upon 23 particles. Now this is our second relation, which is nothing but derived from the same formula, just by replacing, as we know that the atomic mass is nothing but equal to the 6.022 to the power 23 particles, we can replace the atomic mass with the number of particles and given mass with the given number of particles. Now these two are our formulas to find the number of moles. Now let us do some numericals to clear this concept. Before starting the numericals, let me clear one more thing for you all, that is in case of elements, we use the formulas that the number of moles is equal to the given mass upon atomic mass, or another formula is the number of moles is equal to the given particles or given particle or atom divided by 6.022 into 10 raised to the power 23. Whereas these are the two formulas which we'll use in the case of elements, as the number of the particles which present in an element are considered as atom, whereas in case of compounds, the particles which we consider is called as molecules. So the formulas are even same, but their notation will change, and this create a problem in the student's mind that the formulas are different. But basically the formulas are the same, but their notation just get changed. The number of moles is equal to the given mass divided by the molecular mass, whereas the second formula becomes the number of moles is equals to the given molecules or particles divided by 6.022 to 10 raised to the power 23. Here the formulas are same, but here we will consider the atomic mass and here we will consider the molecular mass. But the concept of the formulas again is the same. Now I think you will get clear the case of elements and compounds. Now let us start with the numerical part. One more thing which I want to just clear with you all guys is that from both of the formulas we can again create a relation, that is both the formulas are equal to the number of moles. So we can also return that the given mass is equal to the molecular or atomic. Now I will consider the one that atomic mass is equal to the given particles divided by 0.022 into 10 raised to the power 23, as these both are equal to the number of particles, so we can also just equate them. I written this because we will require to use it again and again in our numericals, and we can also relate a third term, that is the number of moles. That if the number of moles in the question are given, or we can say that first of all we will just discuss this one, that if the given mass is given to you and they will not ask the number of moles and they just ask the number of particles present in the given mass, then you just use this relation that you know the atomic mass of the element. They will just give you the name of that element whose particles you have to find. Then you should know the atomic mass, then the given mass will be given, and then you know this number, then you can easily find this stuff. And either if they will give you the number of particles and ask for the given mass, you can easily find out with this formula the given mass. Now let us discuss the numerical. Now let us discuss these 5 problems of mole concept one by one. First we will start with problems on atom cases. Our first problem is how many moles are 5 grams of calcium. Now first of all we will write the formula, that is the given mass is 5 grams and we have to find number of number of moles. So we will use the formula that number of moles is equal to given mass upon atomic mass. As the atomic mass of calcium is 40U, so 5 divided by 40, that is 1 by 8. So after solving this, we will get the number of moles equals to 1 by 8. If you want to just calculate the value in decimal form, then you just divide it. Now let us go to our next problem. That is, how many moles are present? How many moles are 9.033 into 10 raised to the power 24 atoms of helium have? Now here, in this case, number of particles is 9.033 into 10 raised to the power 24, and number of moles have to calculate. So the number of moles becomes the given mass, given particle, divided by the 6.022 into 10 raised to the power 23. So 9.033 into 10 raised to the power 24 divided by 6.022 into 10 raised to the power 23. Now, as in this problem, you can see that the calculation is little bit complicated. So for these type of questions, there is a trick, and that is just forget the point values and just consider 6 and 9, and just by cutting this, that this is 3 3s are 9 and 3 2s are 6, and we can just find the value, and that is 1.5, and just solving this we get 10. Now we will get 15 particles. We have just forget about these because on dividing these two terms, the decimal terms will just affect a little bit our answer. So to make our calculation easy, we just consider these two terms. Whenever your calculation get too much complex, you can just use these type of tricks. Now let us go to our third question. Our third problem is calculate the mass. Now calculate the mass of 3.011 into 10 raised to the power 3 atoms of carbon. Now this problem is based in this formula. Here you have given the number of particles and you have to calculate the mass. Now here the number of particles is 3.011 into 10 raised to the power 23 divided by the number, and here the given mass we have to find, and the atomic mass and of carbon, that is 12U. Now we can solve. Now this is and easily be cut by 1 and 2, and this will get cut, and a given mass will equals to this 12 is going and this, and we will get the given mass as 6 grams. So by this we can easily find out the given mass if the given particles is given to us. Now let us move on to the problems of molecules. Now let us start with the first problem. Now convert 22 gram of CO2 into moles. Now the given mass is 22 gram and moles, number of moles is to be found. So according to the formula, the number of moles is equals to given mass upon molecular mass. So in such questions, first of all we have to find the molecular mass. So for molecular mass, we can find it just by, as we know that the molecular mass is nothing but the algebraic sum of the atomic mass of the terms. Now we can calculate it by this simple trick, that the mass of carbon was 12, whereas the mass of oxygen is 16, but here are two oxygens, so we just multiply it by 2. So 2 into 16 is 32, whereas 12 plus 32 is 44U. So now we will use it as given mass is 22, whereas molecular mass is 44. So the number of moles will be equal to 1 by 2, that is 0.5. This is a very important question because in molecular cases you have to calculate the molecular mass first and then you will use it here in the question, in your problem, and then just find the number of moles. Now let us move on to the next problem, that is convert 12.044 into 10 raised to the power 23 molecules of SO2 into moles. As given particles is 12.044 into 10 raised to the power 23, we will use, and the moles is to be found. Now we will use again the formula given particles divided by 6.022 into 10 raised to the power 23 particles. Now 12.044 into 10 raised to the power 23 divided by 6.022 to 10 raised to the power 23. Now again this will cancel out by 2 and this will also get cancelled out, so the number of moles is equals to 2. So by this, now we have completed the mole concept and also solved all the problems. I hope you have cleared your concepts. Now just practice a little bit more questions or this to clear your concepts. Thank you.